Autocomplete feels noisy or misses obvious prefixes. We'll build fast, relevant type-ahead suggestions as users type. Too many search boxes return junk or nothing until the user types a full word. That frustrates users and wastes clicks. By the end, you will understand how to combine simple prefix search and n-gram matching in Whoosh to return tight, useful suggestions as someone types. I'm Professor Pi, teaching search and IR with simple Python. Autocomplete is a small but critical system. It sits between a user and your data, and it must be fast and sensible for every keystroke. People reach for prefix matching when they want immediate starts with results, and they add n-grams when users expect mid-word matches or typos. Success looks like suggestions that feel instant and relevant, not a flood of unrelated items. At its core, we want two things. First, catch beginnings of words quickly with a prefix index. Second, catch fragments inside words with n-grams. Prefix is terrific for names and commands. N-grams are great for compound words and subword lookup. The trade-off is index size and occasional noisy hits from n-grams, so we blend the two. We will build a tiny toy index, then run prefix queries, re-rank those candidates, add an n-gram index, and finally merge results into a single clean list. The code uses Whoosh and a tiny list of titles that we reuse in each step, so behavior stays consistent and easy to follow. Now we set up the basic index and data. This snippet creates a Whoosh in-memory index and loads tiny title data. It defines a simple schema with a text field for the title and then opens an in-memory index writer to add a handful of short titles. The core idea is to have a reproducible corpus so later searches hit the same documents. Key lines build the schema, instantiate the index in RAM rather than on disk for speed in examples, and loop over the title list to add each document. This step is purely about setup. You get a minimal Whoosh index and a stored title field to retrieve and display suggestions. Next, we try plain prefix matching to get instant suggestions. This snippet runs a Whoosh prefix query to return fast prefix suggestions. It creates a prefix query against the title field using the current input string, opens a searcher, and asks for the top n hits. A prefix query, defined here as a query that matches any term starting with the input text, is super fast because it leverages term dictionaries inside the index. The code picks a small result limit to keep suggestions concise. Important knobs are the field you target and the maximum hits to return. Increasing the hit limit gives more recall, but can slow per keystroke response and produce less relevant items near the bottom. Next, we improve ordering by adjusting how hits are scored. This snippet re-ranks Whoosh prefix hits by similarity for cleaner ordering. After retrieving the prefix hits, the code computes a similarity score between the user input and each hit, and then sorts those candidates by that score. Here, similarity means a measure of shared terms and token overlap, so that closer matches rise to the top. The key steps pull stored titles from the search results, normalize and compare them to the query text, and then apply a custom sort. The adjustable parameter is how many prefix hits you re-rank. Re-ranking a small top slice is cheap, and usually enough to get tidy, human-friendly ordering. Now, we add a complementary n-gram index to catch mid-word fragments. This snippet builds a Whoosh n-gram index to support mid-word matches. It switches to a schema that uses an n-gram style analyzer for the title field, and then indexes the same tiny title set into this alternate index. The idea is n-grams break words into overlapping character chunks, so a search for a fragment inside a word will match. The key design choice is the n-gram size and whether to index character n-grams or word n-grams, because smaller grams increase recall but also noise and index size. This step gives us a second source of candidate suggestions that finds substrings the prefix index misses. Finally, we combine both sources and dedupe the suggestions. This snippet fuses Whoosh prefix and n-gram hits into dedupe suggestions. It runs both the prefix search and the n-gram search, collects candidates with their respective scores, normalizes those scores to a common scale, and then merges the lists while removing duplicate titles. The merge gives priority to prefix hits by boosting their score before merging, and then fills with n-gram hits where prefix matches are absent. The important parameters are the weight applied to prefix versus n-gram scores, and the final cap on suggestions. Tuning that balance controls whether you prefer starts with results or broader substring matches. In practical projects, this toy flow maps directly to a real system. Keep a compact prefix index for instant starts with responses, add an n-gram index for mid-word coverage, and fuse with simple scoring rules to avoid duplicates and noisy items. That mix scales well for small to medium catalogs and gives predictable UX improvements. Recap: it is a two-part Typeahead combining prefix index and n-gram index in Whoosh. Use it when you need fast starts with suggestions, plus mid-word matches. One caveat: n-grams increase index size and can add noisy hits if not weighted carefully. Next step: tune the n-gram size and the prefix weight in the fusion step, and measure suggestion latency and precision as you change them. If short practical IR helps, subscribe and watch the IR videos.